We need to get the ships into the game world and interacting with the environment. Our first step is to create the player ship, get it moving around and colliding with the barriers that we established in the last video using a collision map. Then we'll add the ability to shoot our weapons. Finally, we'll add some visual effects for when a ship is destroyed. Our ship design today is the prototype for all ships that we'll be adding next time. So in our design document, we'll be building almost everything listed here. There's a few dependencies that we haven't made yet, but I'll either add them and comment them out, or I'll leave a note saying a future code block goes here. But first we need to bring in some sprites. Create a group for the ship sprites, and we'll find the file that we extracted several videos back. The sprite includes 20 frames, so we'll rename it. And bring it in. This time I won't forget to remove the black background. We don't need flying boxes. I'll also need to rotate them 90 degrees because I want the resting direction to match the GameMaker direction of 0, which is the standard in math as opposed to the compass point 0. Center the origin to the middle of the ship. I'm interested in the explosion sprite right here. It looks like there's 5 frames, but there's actually 7. 2 of them are blank. Again, we'll remove the background and center the sprite. So I need a couple more graphics, but we can't drag them in as easily. I'll add a new sprite group called New. So I want to create a blaster bullet used by the Hornet ship that we'll test. I didn't see it in any of the assets we extracted, but looking at the game, it just looks like a single rectangle, roughly a pink color. I'll just draw it. Now center it. Now I want to pull one of the frames from the ship's sprite strip to use as our basic missile. I'll crop it a bit, then center to the new size. I think that's all we'll need for assets this time. As usual, we'll start with a create event. First, we'll register the keyboard, and I'll need a reference to the game map. But I know I'll need a reference to the mission control object, the HUD object, and the ship's AI controller. I'll add them now, but I'll comment them out since they don't exist yet. Now each ship will have a priority queue ranking other opponents' ships based on distance. Then we'll add 4 different enumerators. The first one captures the actions ships will take. Now I'm going to take a different approach than usual because I want to demonstrate the idea of bit fields. We'll set each action to a specific bit value by progressively shifting. I'll use a single variable to hold the active actions that we can set and mask with these types to determine what actions are taking place. We'll use the logical OR and logical AND operations for this. Our next enum defines the weapons that we'll use during the game. There's basically 6 options: weak, normal, and strong for both guns and missiles. Next we'll have an enum for the ship types. Now I'm going to use this enum to refer to the sprite frames for the ships, so I want their order to match the appearance in our sprite strip. First we have the truck, the transport, and the stiletto. Then the stingray. Then the Hornet and Javelin. The enemy ships are drawn in a mixed up order. First is the Mark 8, then the Mark 6, and finally the Mark 7. Finally, I want an enum for 3 possible alignments relative to the player: ally, neutral, or enemy. We'll need quite a few variables here to get our ships up and running. I'm going to add all the variables here that we expect to see in the player ship in Mission 1. However, we'll eventually override most of them in the Room Start event depending on the nature of the ship. Now this is how we'll simulate object polymorphism in GameMaker. I've used this trick several times in the last few videos, but I haven't directly called it that. In short, I'll create variables for our test ship here, but eventually I'll use the room start to transform every future ship to whatever we need it to be. Let's start with some ship statistics. I don't have any useful numbers just yet, so we'll make some up. Set the maximum variable, then the current variables to the maximum. Assign an arbitrary speed, ability to use afterburners, and an alignment. We'll need our bit field variable that I'll call actions, a flag if the ship is active, a unique index number for the ship, and we'll make sure the ship is assigned to a wave, which is useful for when we script missions. Now for some basic motion variables. This direction2 variable will resolve our intended direction based on input, add delay timers for turning and firing weapons, and a variable to hold the ID of the last ship that shot our current ship. This will be useful for attributing kills later. We'll throw in a flag identifying if this is the player ship or not. I'll probably change this to false later. The ship type. I'll set the starting X and Y position to be right in front of the traffic department headquarters on the map, since most missions start there. I also want to track the grid position of the ship. Now this leads to our first map script. I want to take the pixel position and convert it to a position on our 201 by 201 grid. Now this is simple as dividing by 32 and rounding down. That way we have to entirely cross the threshold of a new map sprite to be in the next position. We can do 2 of the 4 things listed in our destructor right now. We'll create explosions and free data structures. So we'll create the explosions if we deplete all the armor. Now I'll leave it blank until we bring in explosions later in this video. Under free data structures, I'll deregister the keyboard too. Let's move down to the busiest part of the ship, processing and handling input. The first thing we want to do is clear out our bit field. Now if we wanted to stay in theme here, I'd actually XOR it with itself, but setting it to 0 works fine in the 21st century. Input handler starts like every other we've made, except I want to restrict handling to active ships, and for now just the player. So we'll be trapping for directions, firing, and escape. And I also want the tab key to change weapons, which I don't see here, so let's add that. Now here's the first step in our bit field manipulation. When we detect the key, we OR the action bit with the bit field to set the bit. This way we can use one action variable to reflect every combination of key presses that happen during the turn. Now I'll leave a space down here to separate AI traps. After we've received all the input, we have to process all that input. Now ideally this should happen in a different level of the event chain. We usually want to read all input affecting all objects before we handle it. We'll start with ship movement, where we'll determine the direction of the ship is trying to move. Now here's how we capture values from the bit field. We check to see if a particular action bit is equal to the action field masked with that same bit. If it's true, then we set the ship's intended direction to the result of that key press. Now we'll extend that trick to 2 possible actions for moving diagonally. Now we should capture the difference between the actual direction and the intended direction. And we'll turn the ship towards the closest side. We have to check both directions. We want the ship to be able to reverse without turning, so we won't check for an exact 180-degree difference. Now let's talk about how the direction affects speed. If we're pressing any direction key at all, we want to check if we're already heading directly towards or away from that direction. If so, we need to affect the speed appropriately, either forward or in reverse. Also check to make sure that we're staying within our speed limit. I'll make a placeholder here for shooting. We'll come back to it when the ship actually works. Same thing for other commands. Actually, I think I can put these in here now. Self-destruct is simply removing all of our health, and changing weapons iterates the weapon placeholder. Since we only have 2 weapon slots, we can increment and take the modulus. The effect is inverting the value. Now it's time for a magical collision check. We want to test 2 points relative to the center of the ship. The point on the nose of the ship, which is a length of 16 in the direction it's traveling. Then we'll check the point at the tail of the ship, same direction, opposite magnitude. Then we'll compare the rear grid point with the collision map. If there's a collision, we know the ship is already heading in the reverse direction, so we'll just take the absolute value of the current speed to bounce the ship back. Now for the front point. It should only contact a barrier if the ship has a positive speed value. We need to invert the absolute value of the speed to enforce the guaranteed negative bouncing effect. Now I can already hear some questions. Why not just negate the speed? Why negate the absolute value of a known positive speed? Well, here's why that won't work. If the ship is traveling at a maximum forward speed and hits the wall, then both the negative speed and the negative absolute value of speed will produce the same effect, but what happens in the second step is that the player is still holding down the forward direction key and the speed will be slightly slower on the rebound. The front point may still be trapped inside the barrier. If we used only the negative speed, the ship will turn around again and go back forward into the barrier. Taking the negative absolute value ensures that we keep going away from the barrier on both the first, second, and any subsequent checks. Now this technique works in traffic department because the map design guarantees that both front and rear points can't be simultaneously inside a barrier. Also, the ships can't travel sideways. Below this, we need to add some code to keep the player on the map, but I'll hold off on that until later. Let's just get it working first. Now we need to update the health values and check for death. We'll charge the shields and see if the ship is dead. Now let's step backwards in time and deal with the begin step events. At the beginning, I want to capture the player's position, update the timers, and apply the physics speed slowdown. That's make sure it's 95% of what it was. Now I'll make the framework to handle overriding the default values in the create event. Since I want to use the create event during our test, I'm not going to change anything. Just know that we want to set different values such as health, speed, weapon configuration for each ship type. We'll do it here. Any changes we make should update the health and armor values. No changes now, so this is redundant. Now for the easy part. We'll just draw the ship. Before we test, we have to revisit our camera object from the last video. Remember that I locked the camera to itself. Well, now we need to lock it to the player's ship. To do that, we'll create our first locator script that returns the unique ID of the player's ship. Scan through all the ships and find the player. If not, return an invalid value. Now we need to add our ship to the room initialization. Alright, let's see what bugs I made. Okay, ship moves, collides with things as expected. All the directions and angles work. Well, I think I'm satisfied. Let's move on to weapons. First thing we'll do is make sure there's no fire delay. Then we'll check the type of weapon we're trying to fire. We'll just do the normal gun and normal missile at first. If we make it into this code block, we know we're going to fire, so let's set the fire delay back up. Then play the sounds. We'll make sure we don't layer sounds on each other to avoid an echo effect. So I want to add a different script to handle weapon shooting, because we have many different kinds of ships with different firing configurations. Some shoot 1, some shoot 2, or even 4 shots per fire. So I want to pass the script the gun position on the ship and the weapon type. I'm going to use the numbers 0 through 4, but I really should have made another enum type just to be more specific. 1 and 2 refer to the gun location on the ship. Now I'll make a note of that in the script. But first, I'll make the projectile object so I can reference it. So of all the ships, the 5 gun positions are as follows. We'll have the front and center, which is used for the heavy guns and missiles. Then we'll have the outside pair that we'll be using for the Hornet-class ship and the Vulture Mark VI. Then there's the inside pair used by the Stiletto and the Mark VII. So let's define these positions around the arc of the ship. Missiles tend to be big, so I'll push that out a bit further. The outside cannons are at the left and right edge, and the inside cannons are towards the front but angled. So for every shot, we need to create a projectile object. I'll store the ID of the ship that's doing the shooting, the direction it's traveling, the type of shot it is. Then we'll force a polymorph change to the projectile, just like we do with the ships. Now I'll put it in the room start, but we'll have to call room start manually like this, since there'll never be a projectile in the room when this event is normally called. Now let's add the case for missiles. We'll fire from the center of the ship. We'll need to define the projectile behavior now. Let's reference the map to check for collisions, and I'll need the HUD later since the projectiles appear on the minimap. Let's set some variables to include the source ship, type, speed, a timer, and positions. We'll update the positions each step. Now we need to check for hits. Unlike the ship, I'll check to see if we're traveling off the map. Then I'll check the collisions with the walls. Eventually I want the damage procedure to go here, but I'll skip it for now. Each step will update the life timer and destroy the projectile if it's gone on for too long. So in our room start polymorph event, we'll hold the actual statistics for the weapons. I'm going to reference the sprites here and just make sure there's some differences between the guns and the missiles. The damage values are meaningless right now. I'll save that for the balancing pass. Now let's draw the projectiles. Let's test this out. Blaster fire seems to work. Projectiles are destroyed after one frame is drawn inside the wall, just like the original game. Missiles work as well, which means our weapon changing works too. Perfect. I self-destructed at the end there using the escape key. Let's add some effects to make that more obvious. I'll create an object explosion Give it one variable to hold its lifetime. Then count it down. I'll rely on GameMaker to automatically draw the sprite animations. I don't have any special draw considerations. Now I want to create a brief screen flash that's also in the original game. Same timer. So for the flash, I'll just draw a yellow rectangle that covers the view with only a partial alpha that fades out with the lifetimer. Let's put these effects in the ship destroy event that we skipped earlier. Now let's run a full test. I'll push through a little of the dialogue too. Okay, let's skip to the action. Moving, shooting, colliding, sounds work. Alright, let's self-destruct. I'm calling this good for now. Next time we'll get the NPC ships in here based off of Mission 1. We'll need to bring in the headquarters object to manage ship creation. We'll also try to destroy those ships using our new weapons.